So today we are going to start with a new chapter called complex number. This chapter is very, very important from the examination point of view. Every year questions used to come from this chapter, mainly in West Bengal JEE as well as in your IIT Mains and Advanced. So if you want to answer those questions, you should have in-depth knowledge about the chapter. Okay, so let us start the chapter, and I will request all of you to keep a pen and paper in front of you, because whatever I am going to discuss here are important. So you must write down those notes over there. So whenever you are revising the chapters, you can see these notes and it will be very helpful for you. So let us directly jump into the lecture itself. Before starting the chapter, we must know that the number system that we have till now, we have natural numbers, that is from 1, 2, 3, 4 and so on, which is a subset of whole number. Whole number includes the number 0 along with the natural numbers. Whole number is a subset of integers. Integer is a subset of rational numbers. Rational number is a subset of real numbers. Okay, what is a real number? Real number is basically rational numbers along with irrational numbers. Is it clear? Okay, so we are happy with this number system till date. But the question is how this complex number comes into the picture. But before that, you have to understand what is a new number called imaginary number. What is an imaginary number? Suppose we have been given to solve an equation like x square plus a square equals to 0. If I ask you to solve this, what you say is x is 0 and a is 0. Since here x and a are both real numbers, so only x equals to 0 and a equals to 0 will satisfy this equation. Now suppose we have been given x square plus 1 is 0. Now if I have to solve this, what I will do, I will write x square is minus 1. So from here we can write x is nothing but under root minus 1. Obviously plus minus sign is there. Okay. Now the question is, this root over of minus 1, it is neither a natural number, nor a whole number, nor an integer, nor natural numbers, nor an irrational numbers. So it does not fall in this number system. Is it clear? This number is what termed as imaginary number. Is it clear? And it is generally denoted by a Greek alphabet iota. So iota is basically under root minus 1. Now the question is, this iota equals to root over minus 1, does it help us? Yes, it helps us. Why I am telling you? It's an imaginary number, but it will help us in this way. Suppose we have been given x square plus 9 is 0 and we have said to solve this equation. So what I will do, I will simply write x square is nothing but minus 9. So x is basically plus minus under root minus 9, which is nothing but under root 9 into minus 1. So it is plus minus 3 iota. Is it clear? So we can solve this kind of equations with the imaginary number. But again, this imaginary number doesn't fit in this number system. Yes or no? Where you can put this imaginary number? Not anywhere. Yes? Okay. See one more interesting thing before going into that number system. Iota is under root minus 1. Therefore, iota square is minus 1. Therefore, though iota is an imaginary number, iota square is a real number. Is it clear? And if I just square one more time, so we will have plus 1. So that gives us what? Iota to the power 4 is 1. Therefore, if I tell you iota to the power n is 1, the least value of iota will be 4. Remember, here we are talking about the positive integral value of n, not the negative integral value of n. The least positive integral value of n for which iota to the power n will be equals to 1 is 4. If n is 4 or 8 or 12 or 16, every time your iota to the power n will give you 1. But the least value of n for which iota to the power n is 1 is 4. Okay. Now, we already got iota square is minus 1. Okay. So, we will remember this as a formula. Iota square is minus 1. This will help us to evaluate the higher exponent of iota. See, iota to the power, if I tell you what is the value of iota to the power 500. So you can easily find out by writing this thing as iota square whole to the power 250. So that gives us minus 1 to the power 250. That gives you 1 only. So just by knowing the value of iota square equals to minus 1, we can find out higher exponents of iota. Suppose we have been given iota to the power say 101. So what I will do? You will simply write this thing as iota to the power 100 into iota, which is again iota square whole 50 into iota. Iota square is minus 1. So minus 1 to the power 50 iota gives you only iota. This way we simplify higher exponents of iota. Now let us come that how to incorporate this imaginary number in our number system. It is a very difficult task. You cannot incorporate iota in the number system that we have done. Okay. So for that, a new number system is coming into the picture, which is called complex number. If you can understand what is complex number, then you will easily understand that these complex numbers can be incorporated in our normal number system. Okay. Any complex number, we used to write this thing as x plus iota y, where x and y are both real. Okay. Now, z equals to x plus iota y, this is termed as a complex number. This can be of three kinds. This can be of three kinds. Number one, if suppose y is 0, in the complex number, if y is 0, we call that complex number as purely real number. Purely real number. If x is equals to 0, we call that complex number as purely imaginary number. Is it clear? And if y is not equals to 0, we call that as imaginary number. Is it clear? Now you see, suppose we have been given z is 2. Now my question is, so far we know that 2 is a real number. Now how, sir, you are writing 2 as a complex number? Yeah, we can write 2 as a complex number. That is why we have defined complex number in these three categories. Z is nothing but 2, which can also be written as iota into 0. That is your imaginary part of this complex number, that is y. By the way, let me just tell you, here x is called real part of the imaginary complex number z, and y is called imaginary part of the complex number z. Is it clear? So when the imaginary part of a complex number is 0, we will call that complex number a purely real number. Is it clear? Now suppose we have been given, say, 3 iota. 3 iota means it is basically 0 plus 3 iota. So we can easily see that the real part of this complex number is 0. So this complex number is purely imaginary number. Is it clear? So now, after knowing this, we can easily incorporate complex number in this number system. Tell me how? Because if I write that all complex numbers are the superset, then I will not be wrong. Because complex numbers involve numbers which are imaginary as well as real. So we can say complex number is a superset of all the number system that we have. Is it clear? Just now we have proved that complex number involves with the real number as well as imaginary number. Is it clear? That is why complex number is a superset of all the number system that we have. Is it clear to all of you? Absolutely. Okay. There is one number which is say 0. See, before that, tell me one thing. A number can be either purely real, or the number can be purely imaginary, or it can be an imaginary number. But 0 is such a number, you look at carefully, 0 can be written as what? Iota into 0. Now you observe that the real part of Z is 0, means it is purely imaginary. The imaginary part of the complex number is again 0, so it is purely real. So 0 is such a number which is purely real as well as purely imaginary. Is it clear or not? 0 is the only number which is purely real as well as purely imaginary. Now let us come for some basic properties of complex numbers. Some basic properties of complex number. Let us say two complex numbers we are considering. Let us say Z1 is x1 plus iota y1 and Z2 is x2 plus iota y2. Okay, these are the two complex numbers. First thing that you must remember that complex numbers cannot be compared. Complex numbers cannot be compared. That is, you cannot write Z1 is greater than Z2 or you cannot write Z1 is less than Z2. There cannot be any comparison between two complex numbers. Is it clear? This is the first property. Second one. Suppose if two complex numbers are equal, then we say two complex numbers are equal means in this case x1 plus iota y1 equals to x2 plus iota y2. In that case we will say that real part of Z1 is always equals to real part of Z2 and imaginary part of Z1 is equals to imaginary part of Z2. It happens when two complex numbers are equal. That is, in this case, x1 is equals to x2 as well as y1 is equals to y2. Is it clear? This is when two complex numbers are equal. Okay. Now the third property. Suppose we have been given iota to the power n plus iota to the power n plus 1, iota to the power n plus 2, iota to the power n plus 3. Okay. These are the four consecutive terms of iota. Now if I take iota to the power n common, we are left with 1 plus iota square plus iota cube. So iota to the power n, 1 plus iota square is minus 1 and iota cube is iota square into iota. So that gives us, is it clear? Because iota square is minus 1. Now look at carefully, 1 goes off, iota goes off. So we are left with iota to the power n into 0, that gives us 0. So what we have learned from here is that always remember the sum of four consecutive powers of iota is always 0. Please make a note of this. The sum of four consecutive powers of iota is always 0. Is it clear? Suppose we have been given a question something like this. Say iota to the power 500 plus iota to the power 501 plus iota to the power 502 plus iota to the power 503. No need to calculate this because since it is the four consecutive powers of iota, so the sum will be nothing but 0. Is it clear or not? Now suppose if I give you a question something like this. say sigma iota to the power n, iota starts from say 0 to 24. Now we have to find out the value of this. How to find out? Look at carefully. It will be basically what? Iota to the power 0 plus iota to the power 1 plus iota square plus so on, and it is iota to the power 24. Is it clear? Now, if I make a group, leaving the first term, iota to the power 0 is 1. Leaving the first term, what you will get? You will get and so on. So the last bracket will be iota to the power. Yes or no? Yes or no? So you see, in every case, since these are all 4 consecutive powers of iota and we are taking its sum, so all the brackets, the value of all the brackets will be 0. So ultimately we will get the answer as 1. Is it clear to all of you? So whenever we find the sum of 4 consecutive powers of iota, that will be always equals to 0. So remember this as a property. The fourth one. Suppose we have been given root over of minus 2 into root over of minus 3. How to solve this problem? We will write this thing as under root minus 2 into minus 3. So that will give you under root 6. Yes or no? Because we have been taught that root over of a into root over of b is always equals to root of ab. But this is not correct every time. This is only correct when at least one of these two is a purely real number. At least one of these two is purely a real number. Look at carefully in this case. Root of minus 2, it is not purely real number. Root of minus 3, this is also not a purely real number. So, since there is not at least one real number, so we cannot multiply in this way. Is it clear? So, whenever we face this kind of problem, so what we will do here is basically minus 2, I will write it as root over of minus 1 into root 2 into root over of 3 into root of minus 1. So, that gives you what? This is iota. Root 2 into root 3, and this is again iota. So iota square root 6, and that gives you minus of root 6, and that will be your correct answer. Is it clear? So remember every time that root a into root b can be written as root of ab only when at least one of them, that is root a or root b, is real. Is it clear? Now suppose if I give you root over of minus 2 into root 3. In this case, we can easily multiply and say this is nothing but root minus 6. Why? Because this can be multiplied because this one is a purely real number. Is it clear or not? Absolutely. Okay. Now, let us come for the fifth property. The fifth property will be, we know so far that if I say x square plus y square is 0, as I told you in the beginning of this lecture, that your x is 0 and y is 0, right? In that case only, this equation will have a solution. But if you find that z1 square plus z2 square is equals to 0, you should not write this thing. This does not imply that z1 is 0 and z2 is 0. No, it is not possible. Okay? But yeah, if z1 into z2 is 0, then at least one of z1 and z2 must be 0. z1 into z2 equals to 0 implies either of z1 and z2 must be 0. Okay, so remember this as a formula. If z1 square plus z2 square is 0, that does not imply z1 equals to 0 and z2 equals to 0, as in the normal case when x and y are both real in the equation x square plus y square equals to 0. In that case, we used to say that x is 0 and y is 0. But it is not true in case of complex number. But when z1 into z2 equals to 0, then either of z1 and z2 must be equals to 0. Is it clear? Okay. Now let us come for algebraic operation with complex numbers. Algebraic operation with complex numbers. Let us consider two complex numbers, z1 which is x1 plus iota y1 and z2 x2 plus iota y2. First thing that we will do is addition. Addition of these two complex numbers. That is z1 plus z2. How we add two complex numbers? This is x1 plus iota y1, x2 plus iota y2. So in this case, when we add the real part as well as we add the imaginary part. Is it clear? We add the real part separately, we add the imaginary part separately. Okay, this is the addition operation. Subtraction, same thing. z1 minus z2, in that case it will be x1 minus x2 plus iota y1 minus y2. Is it clear? Normal operation. As we do it in the real numbers, it is same as this. Here we will add or subtract the real part and the imaginary part will be added and subtracted separately. Is it okay? Let us come for the third operation, which is multiplication. So z1 into z2 will be, if I multiply, what I will get? x1 into x2 plus iota y1 x2, then again iota x1 y2 iota square y1 y2. Is it clear? We know that iota square is minus 1, so keep the real part in one bracket and the imaginary part in another bracket. Is it clear? This is how we go for multiplication of two complex numbers. Let us now move for division. How we divide two complex numbers? So now what I'm doing is, I'm just multiplying numerator and denominator with x2 minus iota y2. It is same as we have done in our rationalization of irrational numbers. It is same here. We will not keep iota in the denominator. Okay, for that reason I have multiplied with the opposite sign of iota, whatever it is given here. Here it is plus. So I multiply numerator and denominator with minus iota and the rest term is there. So what you are going to have in the numerator, we are going to have and in the denominator we will apply the formula of a square minus b square. So it will be, so in the numerator we are getting iota square is minus 1. So this one will be plus, keeping the real term in one bracket and the imaginary part in another bracket. Iota square is minus 1. So it is y2 square. Is it clear? Now I can write this thing as always remember one thing, you should be familiar from now onwards, that whatever complex number is given to you, you will always try to write in the form of x plus iota y. Always write in this form. Is it clear? Don't mix it up, because it will be helpful for us. In the coming session, we will understand why it is so. But always try to write any complex number in the form of x plus iota y. X means the real part of that complex number, and this is the complete imaginary part of that complex number. So try to write every time in this way any complex number that you get. Is it clear? So these are all 4 basic operations with complex numbers. Is it clear to us? Now let us move for some problems. The question is, if x is minus 5 plus 4 iota, find the value of x to the power 4 plus 9x cube plus 35x square minus x plus 4. Now it will be not a wise decision of taking the value of x and putting it here to get the value of this expression. That will be not at all a wise decision. So what I will do here, I will do little manipulation from the given condition. That is, x plus 5 is 4 iota in this case. So if I square both sides, so we are having getting x square plus 10x plus 41 equals to 0. Okay. So we will utilize this to calculate the value of the given expression. See how I am doing. First of all, you write down the expression whose value is to be calculated. Now listen carefully what I am saying. You simply write down the expression that we got from here. Okay. Then you think how to get x to the power 4. What should be multiplied with this x square? Don't see the other terms. Only see the first term. What should be multiplied with this x square to get x to the power 4? Naturally it will be x square. So now x to the power 4 we got. Now from here after multiplication we are getting 10x cube. Oh, I'm so sorry. This is cube. Here we are getting 10x cube. But in the question, it is 9x cube. So what I have to do, I have to just subtract 1x cube from here. Have you understood this? Next, we are getting 41x square. But we are actually having 35x square. So what you have to do? You have to subtract 6x square. Right? We are left with minus x and plus 4. Now, this expression, the value of this expression is 0. Therefore, we are left with minus x cube minus 6x square minus x plus 4. That is why we have done the problem in this way. Because every time we will take the advantage of writing x square plus 10x plus 41, because ultimately we will put the value equals to 0 and our calculation will be simplified. Right? So again in the next step, you write down x square plus 10x plus 41. Then you think, what should you multiply with x square to get minus x cube? Naturally it will be minus x. So after multiplying we are getting minus x cube. Now we are getting here minus 10x square. But we are actually having minus 6x square. So what we have to do? We have to simply add 4x square so that it will get nullified and it will give you minus 6x square. And the third term will give you minus 41x, but we are having minus x over here. So what you have to do? You have to add 40x. Is it clear? And we are left with 4. Have you understood it? Again you put the value of this is 0. So we are left with the expression, this one. Is it clear? Again you write the same expression 10x plus 41. Then you think, what should you multiply with this x square to get 4x square? Obviously it is 4. Now 4x square, it is matching. 40x, it is also matching. Now we are getting 164 after multiplying with 41 with 4. Right? We are getting 164 after multiplying 4 with 41. But we are having only 4. So what you have to do? You have to subtract 160 to get plus 4. Again, this part can be replaced by 0. Therefore, the value is minus 160. Have you understood it? See how the problem has been solved without any major calculation. Only by knowing the method of doing this sum, you can solve this problem easily. Have you understood this? Okay, let us take another problem. The question is, find the real part of 1 plus iota whole to the power 100 and its imaginary part. Okay? So I can write this thing as 1 plus iota whole square whole to the power 50. So if I break inside with the formula of a plus b whole square, we are going to have a square plus b square plus 2ab whole to the power 50. That gives us what? Iota square is minus 1. So it will be 2 iota whole to the power 50, which is nothing but 2 to the power 50 iota to the power 50. Iota to the power 50 can be written as what? Iota square whole to the power 25. Again, we know that iota square is minus 1. So it will be 2 to the power 50 minus 1 to the power 25. Is it okay? So it is coming to minus 2 to the power 50. Right? Now, there is no imaginary part here. So we can write this thing as iota into 0. Therefore, the real part of the complex number 1 plus iota whole to the power 100 is nothing but minus 2 to the power 50, and the imaginary part of this complex number is nothing but 0. Have you understood the problem clearly? Absolutely. Okay, let us take another example. In this question, we have been given that if x minus 2 plus y minus 3 iota by 1 plus iota is 1 minus 3 iota, then find x and y. Okay, so the given expression can be written as, if I cross multiply now, if I open the brackets, what we are going to have? Iota square is minus 1, so this is plus 3. So it is coming to 4 minus 2 iota, which is equals to x minus 2 plus iota y minus 3. Okay? Now, two complex numbers are equal. As I told you in the properties, that when two complex numbers are equal, their real part are equal, as well as their imaginary parts are equal. Imaginary part in this case is y minus 3, and in this case it is minus 2. It is always along with the sign, remember. So from here we are getting x is nothing but 6, and from here we are getting x is nothing but 1. That is the required value of x and y. Is it clear to all of you? Absolutely. Let us take another problem. More we solve problems, more we will be clear about the chapter. The only way of be confident in a chapter is doing problems, nothing else. Find z if z plus z cube is equals to 0. So we have been given z plus z cube equals to 0. So from here we can write, if I take z common, it is z square plus 1, which is equals to 0, right? So as I told you that when two complex numbers, when they are multiplied and it is equals to 0, then at least one of them must be equals to 0. So here either z equals to 0 or z square plus 1 equals to 0. That implies z square is minus 1 implies z is plus minus under root minus 1, which gives us plus minus iota. Is it clear? Therefore, the solution is either z is 0 or z is plus minus iota. Is it clear? Let us take another problem. Question is, find the smallest positive integer n such that 1 plus iota by 1 minus iota whole to the power n equals to 1. Okay? So now we have to find out the value of n, which is smallest positive integer. So for that, what I am doing, inside the bracket I am multiplying with its opposite sign, whatever given in the denominator. That is 1 minus iota, so I am multiplying numerator and denominator with 1 plus iota. So what we are going to have? In this case, we are going to have what? 1 plus iota whole square divided by 1 square minus iota square whole to the power n equals to 1. That implies, if we open the bracket inside, we are going to have, and in the denominator iota square is minus 1, so we are having 2 whole to the power n is 1. So that implies Iota square is minus 1. So this and this goes off. So we are left with 2 iota by 2 whole to the power n is 1. So that implies iota to the power n is 1. Now what is the least value of n for which this one will give you 1? As I told you before, that the least value of n will be 4. So in this case, your answer will be 4. Is it clear? Absolutely. I've given a bunch of problems based on whatever we have done so far. Check the PDF link given in the description box, download it and try all the sums given there. Send me the answers in the comment section so that I can check and validate its authenticity.